Today, I'd like to walk you through Minerva's approach to AI and show you how it can be used in a number of different applications. So first off, who are we? Minerva is a Vancouver, Canada-based company, and we deliver explainable cognitive AI solutions in geospatial analytics to solve problems in mining and natural hazards. We're a diverse team bridging the gap between cutting-edge cognitive AI research and practical geospatial applications. While Minerva itself has only been around since 2017, our technology has been under development for almost 20 years. Recently, we've released a series of software tools under the banner of Terra Mining AI, with solutions for every stage of the exploration and mining process. Based on these successes, we're now expanding our verticals to apply these tools to solve problems relating to natural hazards. We've got alpha stage prototypes built out to cover landslide, flood, and wildfire risk, and we're seeking out partnerships to build these products out into turnkey solutions for the insurance sector. So what kind of tech-based solution do we offer? Minerva's cognitive AI is different from the conventional way that most of us usually think about artificial intelligence. At its core, we're attempting to train the computer to think and reason like a human expert. To do this, we don't use neural networks or statistics or fancy machine learning software. Instead, we offer tools and support for our clients to develop conceptual models using knowledge graphs that describe a particular domain in words, not numbers. Once defined, we use this information that's been encoded into the computer and apply our reasoning engine. We call it the Reasoner. The Reasoner allows us to make comparisons of similarity between physical entities, leveraging the power of our knowledge graph to compile a wide array of various datasets. On top of that, since we're not using black box systems, the solutions presented by our workflow are completely explainable, so you can audit the results for yourself. Now, that's all well and good, but you might also ask, what does it actually do? How does our technology apply to natural hazards, and what is the problem we're solving? Looking around in the news, it's clear that natural hazards are now more frequent and damaging than ever before. Our team realized that, in much the same way that you can use our tools to look for a gold deposit in mineral exploration, you can also look for example, houses that are at risk of flooding. Minerva provides the tools needed to apply our cognitive AI workflow, empowering users to make informed decisions about natural hazards with complex geospatial and other data. This workflow can be applied to a variety of different domains. You can apply it to P&C insurance underwriting to compare two different properties in terms of their flood risk quickly and consistently. For reinsurers, Gaia can help by providing explainable risk assessments that integrate a variety of datasets. Data stored in the knowledge graph allows us to provide richer geospatial analytics than traditional tabular databases. In real estate, the explainable similarity scores can help connect investors with the right properties and to better understand their exposure to natural hazards. Also, linear infrastructure operators like power lines need to understand which segment of their line is most at risk of either generating or being affected by wildfires. So now you have a sense of what we're doing, but what's the big deal? On the bottom right here is a simplified knowledge graph that represents the information shown in the image on the top right. When we look at that image, our minds construct models that are similar to this knowledge graph to make sense of it by linking what we see with what we already know about the domain. For example, we don't just see colors, we see a building there. And that building has a roof, and that roof is made up of a specific material, and it also has a skylight. Many of these elements can be identified using computer vision algorithms applied to satellite imagery, but Minerva offers a tool to help structure that data inside the computer so that it can make inferences about the image content in much the same way that your brain can. So on to those benefits. As mentioned already, one of the great benefits of using knowledge graphs is that they allow you to encode expert knowledge in the computer, so that the information can be used by a reasoning engine to make inferences about data. Another great thing is that they're extremely flexible. Storing your data in a knowledge graph allows you to incorporate a wide variety of quantitative and qualitative data in one place. This means we can incorporate data from sensors as well as satellite imagery and almost anything else that you can provide. I've already alluded to this, but knowledge graphs provide a very rich data storage format. Data turns into knowledge when it's placed in context. Knowledge graphs provide that context and increase the value of your data. On top of that, I want to make it clear that we aren't reinventing the wheel here. We're simply providing our clients with the tools to apply established, tried and true scientific methods, theories, data, and results to come up with expert-based solutions across a wide area, fast. Our results are completely transparent, and we pride ourselves on the explainability of our AI. The scoring system is clearly laid out with no secrets buried inside black boxes. Finally, I'll note that knowledge graphs are widely used, but you may not know it. In fact, every time you do a Google search, you're making use of their Knowledge Graph tool, as they use the context of who you are, where you are, and how you search for it to deliver customized results. Amazon's Alexa and Apple's Siri are also powered by Knowledge Graphs. Now that I've hopefully convinced you on the benefits of Knowledge Graphs, how do we do it? What does it look like to actually step through the Gaia workflow? Here's our 5-step process. First, we start by working with you to build out a knowledge graph. We call this knowledge engineering. We'll look at all the data you want to use and start to develop a model for how those component parts interact. We've pre-built knowledge graphs for flood, wildfire, and landslide hazards, but every application is different, so these can be easily modified. Then we integrate all of the relevant data sets, whether that be CAD model outputs like water depths or information about your customers' properties, and we align that data with the structure of the knowledge graph to put all of it in context, so to speak. Next, we go to work with your experts, using our software tool to capture their knowledge and define which are the important attributes that matter for the risk being modeled. Once again, we've got pre-compiled models for various types of flood, wildfire, and landslide risks, but these can be easily modified to suit your data or your experts. With all that done, we then use the reasoner to compare between the data and themselves or with the predefined models. The reasoner results can then be delivered in various ways, but we like to display them in a web-based dashboard so you can interact with the data and drill down to understand the reasoner scores. This is an example of a flood risk dashboard that we've put together for one of our pilot projects. Here we're comparing the gray house and the crosshairs with all of the other houses in terms of flood risk. This particular result uses about 30 different geospatial data sets, listed on the left side of the screen, to come up with the reasoner flood similarity score. Similarly, you could compare all of the houses in your portfolio with an idealized model of a house at risk of flooding based on your expert opinion or your loss records database. These results can be used to extract actionable insight from your data. For example, an insurance underwriter might have a customer looking for flood insurance whose home sounds really similar to one that they wrote a few weeks ago. They can then search their local knowledge graph network to compare just how similar this new property is to the one that they wrote a few weeks ago, allowing them to price premiums more consistently and more quickly. While this is similar to the typical scoring system that most catastrophe modelers provide, remember that the data are stored in the knowledge graph, so they're placed in context. You can drill down into the results by clicking the Match Report button to get detailed explanations for why exactly, in this case, 123 Oak Avenue is similar to 456 Main Street in terms of flood risk. So to close, I want to summarize what Minerva is all about. We provide explainable cognitive AI tools in geospatial domains where data is limited and the problems are complex. We help by storing and sorting through heterogeneous datasets and putting that information in context. Our domain-agnostic technology has been proven in mining and mineral exploration, enabling rapid adoption of cognitive AI reasoning. We're now looking to apply these tools to the natural hazards industry and are seeking out commercial partnerships to help build them out for insurance, real estate, and other applications. Thanks for listening, and please feel free to reach out to learn more about our geospatial cognitive AI products.